Hi guys, here is MIH. Adapalene is a medication for treating acne which I personally used for a while, and I've been looking into its chemical synthesis that appears to be approachable under home laboratory conditions. Starting from 4-bromophenol and 1-adamantinol, an exotic Friedel-Crafts reaction couples the molecules together, which then undergoes a phenolmethylation reaction to form 2,1-adamantyl 4-bromoanisole. The next step is a very special dual metal catalyzed Kumada coupling to introduce the naphthoic acid group, and finally a basic hydrolysis to afford adapalene. Despite the rather unconventional reaction conditions for the FC reaction and the Kumada coupling, those steps are adopted and replicated by quite a lot of literature, including a paper from OPRD that managed to run the synthesis in a pilot plant scale, so I think that reaction conditions can be trusted and are worth a shot. However, I encountered some unexpected obstacles in the first step of the sequence, so this isn't a tutorial by any means, but just a record of my attempt. And some spoilers, I read through relevant literature again when I'm writing this video script, and it turns out that my reaction actually worked, but I seem to have lost my product during the workup procedure. So here's how I did it. I first oven dried my round bottom flask for the reaction, then weigh out 0.05 moles of both substrates, which are needle-like crystals. I added them to the flask and dissolved them in 25 ml of DCM. The DCM was dried using 4A molecular sieves prior to use. Most of the substrate dissolved, but the mixture remains milky. I then measure out 2.5 milliliters of around 95% sulfuric acid made by boiling down 37% battery acid. The yellow-brown color was due to contamination by plastic, but it shouldn't interfere. I added the acid dropwise to the mixture, and no apparent exotherm occurs. The solution turned to a clear yellow after all acid is added. Finally, I add in 14 ml of glacial acetic acid, and nothing seems to happen. The acetic acid froze during the winter, proving that it is likely pure and free from water. The slightly yellow mixture is allowed to stir at room temperature for 2 days, as the literature required. Now here's what interesting things start to happen. My first attempt of this reaction was at winter, and even after 3 days, no reactions seemed to take place. I followed the workup from literature using sodium bicarbonate to quench the acids and extracting with DCM, and after distilling off the DCM, I'm left with some terry stuff, probably just a mixture of the starting materials. On the second attempt, I chose a warm day in late spring and took note of the room temperature, which was 26 degrees C. The reagents were used in a half scale, or 0.025 moles, and everything else was done exactly the same as the prior attempt. And after the same 2 days, a lot of solid precipitate appeared in the reaction mixture. So indeed, a higher room temperature makes the reaction proceed faster. You can see that the solid has a lighter yellow color than the solution. Now I'll be honest, for just a split of a second, I thought that this may be my product. But I still decided to follow the literature workup procedure instead of directly filtering the solid out and test it with TLC. So I repeated the same workup as before, washing the DCM layer with sodium bicarbonate and water before drying with magnesium sulfate and boiling the DCM off on a hot plate. The hot plate has a temperature regulation and doesn't exceed 200 degrees C, so I'm not that worried about overheating the product. After nearly all DCM is gone, I'm left with a syrupy yellow liquid. The melting point of my product is 147 to 148 degrees C from literature, so there is definitely residual solvents and impurities in it. I directly added N-heptane to recrystallize this crude product. Here I made some deviations with the literature, as they used isooctane instead, and I poured too much heptane than required. I observed that the cold heptane solidified a portion of the yellow syrup into colorless crystals. This is probably my last chance to realize that my product might be crashing out right now. But I didn't, and proceeded to allow all of it to dissolve in heptane, and waiting for it to precipitate out again when I cooled the solution. And it didn't. I just ended up boiling the heptane dry, and I was left with 5.24 grams of slightly pinkish solid. Looking back on more recent literature to find out why the reaction didn't work, I found one that mentions that the product is filtered from the reaction mixture, washed with DCM and water, and allowed to dry. So the precipitate in the reaction mixture is actually my product. Well, that shows that my reaction worked perfectly fine, and using this workup procedure, I can even recycle the mixed acids for another run instead of neutralizing them with sodium bicarbonate. This just makes life so much easier. Anyways, that concludes this short lab notes video, and I'll continue working on the remaining steps of synthesizing adapalene. See you soon.